All right, so this is question number 16. All right, so what we have here, we are talking about commuting time. All right, so is regardless, really is not really important what the question is talking about. You need just to know what are the keywords, right, and what we are expected to do. So here is saying the word average, right? So the word average, so that's going to be 25 minutes. So it's giving you the average, it means, right? And then is telling you another word if you assume that the commuting time are normally distributed. So normally distributed here is another keyword. So it's telling you this is a bell shape, but it did not say that standard normal distribution. So it's just normal distribution. It means the mean could be different than 0 and standard deviation could be different than 1. And that's actually what's happening here. They give you the mean, which is the average, equals to 25, all right? So we know already it's a bell shape, and we know the mean is 25. And then they go on and they tell you that the standard deviation, all right, standard deviation here is 6.1. As again, this is a confirmation that standard deviation with the sigma, all right, is not equals to 1, is in fact 6.1. All right, so that's a confirmation that you're in normal distribution mode, not a standard mode. All right, so they wanted to use the calculator, and what you want to do here, we want to select we want to figure out what the probability of x greater than 30. All right, so this is the mathematical notation. What will be the probability of x greater than 30? Again, I think the best way to understand this is, all right, although we're going to use the calculator, all right, don't rush to the calculator, but you need to understand the problem first, right? So let's go to the graphing. Okay, so our graphing, we know we are in Bell normal distribution, right? So the normal distribution, again, is going to be a nice bell shape. And what we have in the middle, this will be the mean. And if you remember the mean, it was 25 minutes. Now, beside the mean, they give you the standard deviation, which is sigma, and sigma is going to be 6.1. All right. So now, what the question is, what is the probability of x? I think is x is greater than 30, right? So x greater than 30. So this is your question. So first of all, you need to identify where the 30 is located at. If this is 25 in here, so we have this already. All right. If this is 25, so the 30, remember the 25 is right there. The 30 should be somewhere here. All right. So this is going to be your x equals to 30. So whenever it's telling you x is greater than 30, so by the way, if you are in normal distribution mode, this axis over here is going to be called the x-axis, not the z anymore. All right, so this is the x-axis, and this, if you want to make a difference, call it x1 if you want to, right? So what we want to do is we want to figure out what are the x's greater than 30, and actually this is really easy. 30 is here, so you're going to go to the right side. So now what you're looking for, as we talked earlier about this, so if you are looking for a probability, you are looking as well for an area. So you are looking for this area in here. All right, if you do a vertical line with the 30 and you're looking for the values, so you go with the values greater than 30 are here, and then you're gonna go with the vertical line, you're gonna hit the graph of the bell-shaped graph, and then you're gonna go along with this. So this is your area that you're looking for, and this is the shaded area that you're asked for, right? So now if they ask you about the probability, so the probability is nothing else than this area. All right. So this area in here, that will be the probability of x greater than 30. So now, once I understood the problem, what do I need for my calculator? All right. So the calculator will require the lower bound. So the lower bound is obviously 30. And we require the upper bound. The upper bound obviously is infinity, because this is going to keep going, right? So the infinity, if you remember how we type in infinity, is 1, e, and 99. All right. So that's the infinity. Let's see how can we do this one on the calculator. So what you're going to do first, well, this function, you can find it under distribution again. So you're going to go second distributions. So second distributions, and what you are looking for is the normal CDF. All right. So every time you are calculating areas is a normal CDF. All right. So normal CDF, enter. So here they are asking about the lower bound. So the lower bound is, we say 30. So you're going to type in 30 instead of that. The upper bound, we say, is plus infinity. So we're going to type 1. The e is over here. So you have to go second and comma. That's e. And type in 99. All right. Now, be careful about the mean. The mean has changed. It's not 0. It's 25. So you're going to type in 25 there. And for the sigma is 6.1. So 6.1 here. And I think that's all, right? So you're going to go in, you're going to enter, you're going to paste, enter, and that's it. So what does it mean here, this number? It means that the area, all right? So this is the area inside is equal to 0.20620, all right? In other words, this is going to be 0.20620. All right. Now we're done with this question. So that's all what you need to do. What you want to do is figure out how many digits you need to round. All right. So it's asking you at least 4 digits. All right. So what you're going to do here, you're going to type in 0.2062. I think that's enough. After the 2 there is a 0, so if you round it, you're going to stay as it is, right? And let's check it. Okay, great, it went through. So now we have very similar question, but the inequality changed, right? So x is greater than 30. Here is telling you x is less than 23. So x is less than 23. So I'm going to use exactly the same chart, and probably I use a different color and do it, right? All right, so here we get this. We want to figure out the probability of x is less than 23. So again, we need to figure out what is 23. If 25 is in the middle, 23 should be somewhere here. All right. So I'm going to call it x2 equals to 23. So if you remember, x less than 23, that means I'm going to have to identify, first of all, the x is smaller than 23, and that's going to be the left side. All right. And I need to define the area, so I have to go up. I have to follow the bell shape, and this is going to be my area that I'm looking for, and the inside would be this. So this is the area I'm looking for, right? So I am looking for this area. What might be? Again, what I need the lower bound, I need the upper bound. All right, I need the mean and I need sigma. So the mean and sigma are the same. The lower bound right now is right here. So this is minus infinity, by the way. So it's going to be minus 1 e to the 99. All right. The upper bound going to be this one. So this is my upper bound. This is my lower bound. All right. And this is my information I need. Okay. So I'm ready to plug everything in the calculator. It's the same process. Second, go to distributions. You go to number 2, enter. And then the lower bound, you have to type in negative. So make sure this is a negative, this is a 1, second, and comma over here, which is the E, and type in 99. All right, so that's the first one. The upper bound, I go down. So whatever there, I clear it and put 23 instead. And then I'm going to keep the same mean, same standard deviation, and paste it. Enter, and enter again. And this should be your answer. So the answer, remember, is 4 digital numbers. So the answer would be 0.3715 and 0. So you need all this and you round this. Okay, so you're going to stay the same. Let's go and plug it in. All right, so the answer is going to be 0.3715. And let's check it. Okay, great, we're done.